The next speaker is Andreas Erben. Andreas spent most of his professional life and career, over 25 years, integrating backend applications, first between enterprises and then between startups, and currently helps customers as a trusted advisor, external CTO, and innovation consultant. He's working at daenet, and he's going to talk about foundations of the Metaverse, Azure Spatial Anchors, and understanding the 3D space. So welcome, Andreas, to Athens, and thanks a lot for being here.
Camera action.
Camera action. So please welcome Andreas.
Okay. So, so let me talk about myself then briefly. My name is Andreas Erben, as you have heard already. So, Moment. Oh, that's me. Okay. Great. So, am I good? Okay. So, so the talk is Foundations of the Metaverse, Azure Spatial Anchors, and Understanding 3D Space. I hope I will not make it too vendor-specific, but give you my spin on the Metaverse, some of the things that I think are relevant, and then talk about some of the technologies that are relevant for, let's say, next steps. About me, I already dabbled with virtual reality in the 1990s in a research context at a university in Germany. I live in the United States now, but work for a German company. And, but there was no money in it. So I started working for enterprises, but around 2014-ish, I started playing around again with Kinect, the thing with the Xbox where you dance, and then HoloLens came along, and I mixed into this mix also applied artificial intelligence and IoT, because overall I realized that this whole backend integration stuff, there must be something more. There must be a new wave of computing coming, and that's what I will start talking about with a little anecdote. My slide, I guess, I'm not good at designing. As you see, HoloRoo is the little kangaroo, a little kangaroo that we designed as a mascot for basically applications, as a startup, and maybe as a guide to guide you through the Metaverse. Yeah, but there's something interesting that happened. So we had this designed by a character artist, and the character artist and 3D modeler drew every strand of hair. And when it was the first time in front of us, and I hope my audio is not good, then it looks pretty cute, and it follows through on. That's the final version, actually, but there's something happened the first time. Yeah, I mean, you see it standing in front of you, but there was something different about it. And what was different, and we felt like a little bit, something is wrong, right? And it's a cute kangaroo. I can tell you more about it later. But it has a function here. This is an application. It's an Easter egg hunt. You explore the space and find the Easter eggs. And when you found one, we hide the Easter egg in the next more difficult space. So overall, you explore the whole space. Because scanning three-dimensional space is a thing that you still need to do often, right? But there was an issue. This kangaroo was designed semi-realistically, had claws. And something triggered in our limbic system, in our brain, you have this 1.60 meter kangaroo with a big body standing in front of you in 3D, and it feels different. It feels different compared to when you see something on a two-dimensional screen. So we went back to the artist, and he was really, really sad and upset, and we learned a lot from interacting with creatives as typical engineering mindset people. And, but we convinced him to remove the claws, and everything was good then. But the takeaway is when you build an application in three-dimensional space, you're literally invading somebody's space, right? So there's something you need to be conscientious of, you need to be respectful of this third dimension. Taking a step back, a big step back, is where do we come from? So where does computing come from? So initially it was an innovation to have a computer at all, the difference engine, Babbage, and then this is how you would develop software in a computer. You would plug wires, right? Then we had punch cards. Punch cards was revolutionary. You could change the programming of a computer almost on the fly. And then we had a keyboard and a terminal. Suddenly you could type things, and things would happen in real time. It was almost magic. And then we get to the era where most of us still live nowadays. This is a mouse. The first prototype of a mouse, invented in 1963, and the first integrated terminal with a graphical user interface and a mouse and a keyboard, 1968. Yeah. Now you may say, like, hey, we got touch. Yeah, well, but touch was also invented in 1965. So this is like over 50 years ago. All those technologies, 54 years for the integrated terminal, where you which dominates how we work these days. We have better devices, beautiful screens, smaller pixels, bigger screens, but fundamentally nothing changed. We look at the computer, we need to learn how to interact with the computer and do things how the computer wants us to do them, right? And then we had even the smartphone. The first smartphone was a Simon in 1992, 1994, yeah? Now, the question is could there be something more? And so the thing is, this next generation of computing, you have also this thing, personal computer, web, mobile and cloud, and next gen. What is this next generation? And personally, I think it is to deal with three-dimensional space. So let's look at the metaverse briefly. Where does it come from? Where does the term come from? You heard that Neil Stephenson, 1992, I believe. Oops, that's the agenda. But when did people start talking about the metaverse? So this is Google Trends. Finally, okay. We go back, let's say go back 5 years. Yeah. You see, nothing much happened in all this time, and then suddenly around like last year, 2021, we had a blip. This blip was when Microsoft had the keynote of the Ignite conference, and Alex Kipman was allowed to hold the keynote of the Ignite conference in three-dimensional space, and all space VR, expanded with some stuff, and used the term metaverse. Then there was a second blip when NVIDIA also used that term on their conference, and this really big blip is when Mark Zuckerberg decided, I need to name Facebook Meta. Yeah? And since then, everybody is in on that term, for whatever reason that is. Okay? I will try to give you the slides later on. It may take me a few days to get them shared, but you will get them. So everybody has a different definition, but you see a few common things like something cyberspace, or it's something to do with virtual, or synchronous communication. So it has something to do with virtual and with interacting and so on. McKinsey has a relatively all-encompassing definitions where they say it's a collective virtual space created by the convergence of virtually enhanced physical and digital reality. So it's device independent. It's not owned by a single vendor. Important. So Minecraft is metaverse-y, but it's not really metaverse. And then comes the other part. It's an independent virtual economy enabled by digital currencies, non-fungible tokens. I would argue that metaverse doesn't need it, but it can benefit from it, but we will get to that also. So metaverse use cases, and I will not get into the details because we do have very limited time here. So it's everything from running simulations and support and training and so on to fun things, the virtual tours and onboarding. So it's basically, it tries to be a mirror of things we can do in real life. Yeah? And this is just another slide of examples from gameplay in immersive spaces and new customer experiences and so on. And then more on the industrial side, like a lot of people think of it as the next step of IoT, Internet of Things. It's basically simulating things and having them in 3D, integrating the data streams, and so on. So example use cases that are a little bit more real that we did ourselves, that's a medical training situation. And the key point here is that this device, that's a HoloLens device, and sorry for the choppy video, that's a stenting procedure. And a lot of people cannot grasp what stenting is, right? So, but here, you would be able to have, different people would be able to wear like a HoloLens device, see this thing in the same spot and point with their finger right on that wire and say, what is this, right? So there's value in having a three-dimensional device that is aware of each other's location. Yeah, that's the key point, key takeaway from there. For who would buy it, patient education, but the device companies, those little wire meshes, they cost thousands of euros. So they sometimes like to do marketing and differentiate themselves. Digital twins, that's an industrial barcode reader, and we couldn't place a marker or like a 2 QR code on the real thing, and we wanted to visualize, actually the vendor, the company of the barcode reader, Lloyd's wanted to visualize the scanning field, which you don't see, it's invisible, and you don't see the internal components of it, right? So we set it up and positioned it exactly over the physical device, a digital twin, and then we got access through services, through the telemetry of that device, meaning if we would scan a barcode now and hold it in here, it turns green, the EAN code shows, and so on. The takeaway from this is that it enables us to show the real information that may be invisible to physically where it's relevant. Yeah? This could be a big factory floor, or it could be something small like this. Yeah? Now, what are the building blocks? When we looked at the computer, it was all 2D and you work with the screen, right? But now we in the virtual reality, and this enables new things. You wear a headset. In the most simple case, you have a concept of gaze. What am I looking at? Either by my head pointing there, or I have eye tracking. So we can reason on that. An application can react to that. We could make a heat map. What is somebody looking at? And gain insights. What is interesting for customers? We have gestures. The learned gestures like these air taps that Microsoft did, so you don't confuse it with a real gesture. Or it could be natural gestures, like I grab something. I would grab this microphone and adjust it, and that would be a gesture that's more natural. Because one of the goals is, again, as I said earlier, that we want to make computers more understand what we want, understand our intent without needing to learn to speak computer. Like we grew up as toddlers, we put stuff in our mouth, so that's the type of interaction that's more natural for us. Voice commands could be anything from like language, like I'm speaking here, and like an advanced AI, OpenAI's GPT-3 may understand what I want to do and derive the intent, but it could be also something simple like next slide, stop application. We have controllers still because that controllers are due to that the sensor technologies that exist today, they can do better with those controllers, with those markers, so they have additional tracking systems. So sometimes when you want to be very precise, even though hand tracking works now, you may want to have a controller, and then there comes the cool stuff like spatial sound. Spatial sound, when you build an application, it's not about 3D only information and visual information, but also 3D sound to make it feel right, feel real, but also to help user attention. Of course, you need to think about accessibility, but how do you direct attention to when something interesting happens behind you? A big problem for virtual movie making, like so you play sound and maybe people turn around, otherwise you need to show arrows. And now finally, the world coordinates and spatial mapping, so where we will talk a little bit more about. World coordinates is just the ability of those systems to agree on a coordinate system and to find things. Like if I have this trackball here and I put it here and it would be in those world coordinate systems and we agree, then you would find it on your device having a virtual representation of it exactly here. And we would also know where we are relative to each other. And then spatial mapping is the ability of those devices to scan the three-dimensional environment in some way, to have like a mesh or internal representation of it that they can reason about and interact with. Yeah, so now that was more from the virtual reality side still, but now Metaverse, right? So some of this is overlapping, right? World, space, and location. Location where we are, the space where the area we interact with could be the meeting room or the zone in the zoning in an online multiplayer game, and the world would be then like the whole, I don't know, the whole expansive world of some game, for example. Yeah, and then you could say, how do you go across worlds? That's a problem not solved yet. Presence, what you know on WhatsApp, on your Teams, is I'm online, I'm offline, I'm available on Xbox, I'm playing this game. In the Metaverse, it could be more, where am I at, who am I with, and more information that's relative to your location. And then you have things like state, persistence, synchronization, communication, interaction, network, and audio. Those are problems that have been prevalent in the gaming industry for decades. So it's not groundbreaking new, but now suddenly the big technology companies need to solve those and incorporate that. So you need to have low latency, so the 5G is going to be important. You need to have good networking connections, good protocols to do synchronization and so on. And what my previous speaker also mentioned, representation is important, that you feel represented, that you have an avatar that you can identify yourself with. But representation could also be more abstract, could be just metadata. It could be as simple, digital twin could be a configuration file that defines how, let's say, this conference setup works here. Yeah? So in Azure IoT, for example, configuration files for IoT edge modules would also be called digital twins. And now this big unsolved problem, cross-world interoperability. So there was a big announcement recently. Meta agreed with Microsoft, and that's a big first step, that they will make their avatar systems compatible, so that you have your Horizon avatars, maybe you can use them in Teams later on and so on. How exactly, I don't know, but that's a big step for interoperability. Now what about blockchain and crypto? Yeah? If you put Metaverse in your LinkedIn profile, I guarantee you get a lot of crypto bros and sisters who are going to contact you and sell you the next best NFT and consulting and whatnot. So there's this gold rush attitude. They try to build their metaverses and sell the virtual boat pier next to Kanye West or the location on a virtual map next to the White House or whatever you like, and they make it like as a sparse resource. It's not really sparse unless this platform takes off. If one of those platforms is the next Facebook, then those virtual locations will be super valuable. If not, then your money's gone. Yeah. So the similar thing, like NFT NFT can be important to prove what you own, to have a representation of it. Similar with coins as a way to pay things, but the key value would be a way to do decentralization, to move maybe this Adidas shoes that you got or this Prada bag and go from horizons to teams and have the same Prada bag. How do you do that? You could use NFT for that. The protocols are not there yet. The technologies of NFTs and so horrible. They wouldn't scale, right? We're not there yet. And you will see decentralization. Oh, it's too complex. And you have crypto wallets in one company goes bust, all your NFTs are gone. So those things will still happen. So this is not a solved problem yet. Yeah. Now, Microsoft Mesh was announced at Ignite, as I said, 2021. This is just roughly how they envision it. You have devices, you have a core platform. Oops, my Apple Watch thought I was talking to Siri. And a lot of things is just things you do in all applications, like billing, infrastructure, graph, identity, right? Then you have some capabilities, and we'll cover some of those. That's more relative to the 3D aspect of it. And then, of course, you want to have an SDK and applications on top of it. The Mesh app, where you can interact with Outspace VR, the Poor Man's Horizon, maybe. Here. Actually, it's pretty cool as a platform to interact in, but technology is a little dated. And then Microsoft Teams, where they have now at least avatars, right? So what happened after the promise? Where is this unicorn Microsoft Mesh? It's not released yet. You have the Mesh app. Not much news. And you have Teams because Microsoft learned that this is actually hard. I don't work for them, so I can say this is hard. And so what they wanted to do is an SDK, they took a bit too much big bite, and now they're learning to be their own best customer, right? So this is like, for example, you have Teams now in some preview program. I'm allowed to show this. So instead of a video, it would follow, you lip sync approximately, and you can have emojis and then and so on. So if you have a bad day, a bad hair day, or tired in the morning, you could use something like that, yeah? Yeah, okay, so let's move on. Quick look at Azure, and I don't know when the time is. Okay, we have, sorry. So Microsoft Mesh here, the capabilities I mentioned, there's some things already existing in existing services we have in the cloud, at least in the Microsoft cloud. Other vendors have similar things. Multi-user sync is something we haven't solved yet, really. But holographic rendering is something we have. We have spatial maps to some degree, and we have also, to some degree, representative avatars, right? So let's look into what is this whole spatial understanding things. Yeah? So you want to interact with the environment, and I roughly divide this into the left side and the right side. We have locations and something we call anchors and movement. Basically, you analyze where somebody is, how are they moving, and you could do interesting things, like if you have a headset on and you have a weird posture, this system could recognize it. It could give you a warning that maybe you need to increase your usability of maybe of the workplace you're in it or something. Like you could have this heat map again, like you could analyze how long has somebody been where, how many people. You could do follow breadcrumbs, like if I would be walking here and that kangaroo would be following me, right? I would be leaving breadcrumbs behind. And then this whole thing with anchors, which I will show later on. And then this other part is you work with the mesh. The mesh is just, I use it as a term for what those devices see and how they scan our environment, and you need to do something with that. Because those are sensors, visual sensors, and they create messy output. So you need to optimize that output. All the frameworks do it for you. You need to solve problems like find a plane equation. Where's the floor? Yeah, find me free space to put a virtual object. Yeah? So what is a spatial mesh? Again, I will not read it, but roughly it's a bunch of triangles. It's actually dots with the connections. So it's triangles that define, it's an approximation of what the geometry of the 3D space is that those devices see. Some devices do that with depth cameras, time-of-flight cameras like HoloLens. Some do it with RGB cameras. The technologies are pretty advanced nowadays. And for HoloLens, you don't have much control what they do with those meshes, but you can ask it, give me your mesh in a specific resolution. And it will become more apparent when I show you a video later on. And back to that simple question, how do you make a plane? Like making a plane equation is math, roughly, right? So you could have 3 corners, 3 dots on a plane, have a plane equation, put a table on it, and if it's like a bistro table, yeah? Or you could have select more points in space, like and average it out, or you could have all sorts of algorithms to try to solve that, or maybe there's an AI somebody built, could also be, right? So spatial understanding and scene understanding, what is this? This is more like the higher level of understanding environments. For example, identify a wall, the ceiling, and furniture. There could be a chair. What can I sit on? Yeah. Now, how's it done? It's not magic. It's math. There's logic, and there's like math you implement, and there are libraries, and there's a few links with examples in the slide. Or it could be something that a vendor has a pre-trained silicon to do this for you. Yeah. For example, this is what Microsoft does, and don't read the code, it's just giving you an idea about the type of things you're dealing with for spatial understanding. So basically they have a high-level query language where they say the surface height is between 0.25 meter and 0.6 meter. You have one surface, and it's rectangular, and the rectangle lengths are not too small, not too big. And by the way, it's not a couch, because we have defined the couch elsewhere. So it's some type of query language in that sense, but it works behind the scenes on a lot of math. So, okay, we have vectors, normal vectors, multiplication, difference to the wall, the difference to the floor, and all those things that need to be calculated somewhere. There's a C++ component, again, source code is available from Microsoft, not from me, and you can play around with that, basically. Now, the other part is where you don't control the granularity of it, and you cannot improve on it, but that's, for example, baked in HoloLens 2. They have basically a runtime that you just say, hey, runtime, I'm interested in scene understanding. What do you know about it? And so application process basically talks to the runtime gives information, and you get what's the wall, what's the floor, what's the ceiling, what's the platform, but you do not get it so granular. What is a couch, for example, right? So let's look at the brief video, and I will have to skip a little forward through it. So this is how it starts. Like in most of the situation, you need to start scanning your environment. You walk around, and at one point, the device starts picking up the environment and starts trying to fill those empty spaces. So your task is, and those will be stored. You only need to do this at the first time. Scan your environment, look under those tables, under those chairs, make it as good as possible, right? And at one time, you're done. Yeah, at one time you're done, and then you complete it, and then you have here UI, and you see those triangles are already cleaned up a little bit. That's what this tool also does for you. And here one of the problems is find me something to sit on, right? Find me something to sit on, and that's a demo application, also free, downloadable in source code, and it marks those chairs for you. So you could put this virtual kangaroo on a chair. Yeah. Another example is I've put something on a corner of a table. It's like, and this is all, again, those queries that I've shown earlier in that syntax. Oops, and then I misclicked. And let's jump a little forward, because we're short in time. You will get the videos, but the point is, like, find things, find larger spaces on the floor, find larger spaces on a surface, or find the biggest wall in that room to put your movie theater screen on, for example. Yeah, so those are typical things. Now this is spatial scene understanding, as in contrast to that, which is like a lot simplified. It comes almost immediately, and it's not as granular. You see, here's a wall, here's a background, there's a platform, and you can do some things with it. And it builds, like the other one, an internal representation of what's in your area. And you can also make it smaller and have a dollhouse model and look in, and so this bed is now here. And think of this as scale. This could be a factory, right? You could have a factory minimized and see where everybody is in that factory. And now something real, let's talk physics, right? So you could put a virtual object on the bed, yeah? Or throw objects on that platform and the balls start rolling off their platform, for example. Because behind the scene, of course, it's code, but there are 3D engines, like gaming engines, Unity 3D, for example, they provide you those tools. And it's not really hard to do that. There's sample code for all those things. But this is an idea, like, still, how is this magic done? Like, basically, the frameworks give you information, like what's the platform, and then you put something on it, and hopefully magic happens, yeah? Oops. Okay, so I have the demo links also for later. Now, existing cloud capabilities, I will briefly cover them, what is remote rendering? Remote rendering means you have a headset on, and you want to display something that it cannot render. Those CAD models, they have millions, can be 20 million polygons, and your headset maybe can render 150,000, 200,000, 400,000, but not that amount much. Otherwise, your brain would be really heating up from the heat and would be really heavy. You would have to have a big computer on your head. So they can do that. So they built the technology as a cloud service, and there are different vendors having slightly different approaches, where they stream the 3D rendering to your device. What's unique about it is that they try to anticipate your next position as you move and pre-render it for you. Yeah? And then when it comes to you, I mean, you need to have a good internet connection. When it comes to your device, they adjust it a little bit and tweak it a little bit to the right, to the left, or distort the image a little bit, but usually it's not noticeable, and it works fairly well. And the thing is, it's also not the whole screen, it's individual objects. So you can mix local objects rendered on your device and virtual objects. The process is a little bit clunky. You need to upload those 3D assets to the cloud, to a service, and then basically sign up for this Azure service, pay them some money, and then when you want, then it starts rendering and you consume that data stream. Yeah? Azure Object Anchors is, I cannot demo it, unfortunately. You need to have at least a 1 meter big thing currently. It's similar concept, but solves something else. It's, let's say you have a car, like in the picture, and it goes into a shop. Cars in a different position every day a little bit, and they look slightly different. So, but they're similar enough because you have the 3D original design model, and you upload that to the cloud, and then this cloud service is able to then find this car location and then align those virtual cables and so on, or the instructions with the correct locations. Because you don't have a marker in this car, let's say, this is my ground truth, this is my zero, my coordinate. So that's why this service exists, basically. Yeah? Concept is similar, converting 3D assets and then using the cloud. And finally, the spatial anchors. So what is this thing, the spatial anchor, right? So those HoloLens devices, and I forgot it now, it's in the back here, but you have seen them probably. So the big headsets, they have a lot of sensors, and those sensors are mostly cameras, and the cameras just film the environment, and they build some internal representation of what they see. That's not the spatial mesh, it's slightly different. But the goal is that they see enough of it, enough feature points, that they can find their own location again. Other vendors call it visual positioning system, and there's Google works on those things, and Niantic, the Pokemon Go folks, they work on those things. So a lot of companies work in that field, but the goal is always the same. You want to come back in the room and find that mouse, that virtual mouse or whatever it is, at the same spot. Yeah. Now, how does it look internally? This, for example, it is basically a sparse cloud, and this would be, those are three-dimensional things that you don't see it in the image, but basically it's a bunch of dots that describe to the computer how does a scene look like based on things that look visually interesting for it. Yeah? So, and if you don't move things around too much, and if you don't change the colors of the design too much, it works fairly well. One unique thing is, let's say I would have a device and start scanning this environment, and it builds the points cloud of this from this here, and somebody else does it from over here, and they also scan, and then suddenly we want to share this. Then those system has a problem because like this device has never seen this environment from that angle. It doesn't have seen this corner of this here and so on. So you need to have experienced in some form or shape in multiple devices or merge the data, this space from a similar perspective. Yeah, that's a gotcha mistake that a lot of people make. The key thing is what Azure Spatial Anchors does, because iOS Android and HoloLens, they all have those similar systems. This service can translate between those. You can start a spatial anchor on iOS and then save it to the cloud and then find it on Android or on HoloLens. Yeah. Roughly, I mean, I'm skipping through the click. You need to set it up something in the cloud, and you get a key here, and this key when you set it up, and gave them your credit card before. Then you use it in your application, and how does it work? You have a session, and the session is what you interact with the runtime. The runtime, then you provide frames to that session, camera frames, yeah, from Android phone. On a HoloLens, you don't need to do it because it's its own internal runtime. And then anchors get created, yeah, and those have properties. Properties meaning what's my orientation, what's my location, yeah. So basically three-dimensional rotation and location, and then you can have anchors and relationships to each other. So and why do you want to do that, for example? If for this a room this large, I want to have anchors maybe every 5 to 7 meters. Because, you know, the problem is like the lever effect, like if I move my arm like just like a fraction of a degree, like over there it's 2 meters on the other side of the room. So, and the same thing happens with an anchor. It's a visual system. If things are too far away, then the system will not be good enough. So we will need to have several anchors. So you have relationship between anchors. It could be inside a session, or they have another concept. This could be called course location, and I will there's a different slide for that. And then you can retrieve anchors by either unique identifiers, by the relationships to each other, or through the course location. I have slides with code fragments, but we don't have time to go through them in this talk. Course location is a GPS, and 2 years ago I would have said no, but now I say yes, because for HoloLens, even it doesn't have GPS, now you can use an external device. For Android and iOS, you can use GPS also. And then you combine it with Wi-Fi, with the Wi-Fi SSIDs and the MAC addresses. And the Bluetooth low energy beacons, a lot of event spaces already pre-configure the events as Bluetooth low energy beacons. And together, this is basically a footprint, a digital footprint of a three-dimensional location, not to find it precisely, but to narrow down that database lookup. How do I know I'm in Australia or in Athens today? Yeah? So. And am I at the Acropolis or am I here? So those help you here. This is a little demo, how it would work when you, like basically you start, you set an anchor on an Android device, yeah, and then you store it, and it starts, hey, I haven't catched everything, and then it gets saved to the cloud. And then you load it again, and it takes a little bit, and then the anchor loads again, and then you continue with the HoloLens, yeah, and you put something new in the middle of the bed, and then you try to hopefully load and hopefully find both anchors based on the course location. And, well, I know what happens in the video, but it's, the first time you try it is always a bit nerve-wracking, and actually, yeah, it has been here. And the video goes on with a few more steps, so I tried it a few more back and forth. I'd like to show you just a little bit further here. This the new object put on the HoloLens, then loaded on the HoloLens, yeah, and then finally we load everything on Android, and hopefully the thing on the pillow is also there. It's also there. Okay, so this is what you can use it for. You can use it for more interesting things, of course. Videos become available, of course. And then finally, developer options. How do you develop code for it? How do we do this? Yeah, you have gaming engines like Unreal Engine and Unity 3D. You have things like native code, C++, DirectX, also Unreal Engine is in the middle. But you can also use web technologies like Babylon.js, 3JS, and A-Frame, and so on. I don't have time to go into deep thing, but one last thing I wanted to show you here. Like this is a video I created, and I thought I could show it live, but with the problems I had earlier, it's too risky. So this is basically combining GPT AI's codecs with I didn't build it, with Babylon.js, with that runtime, and I basically give it natural instructions. Hey, make a cube, make a sphere, put it next to each other. Now spin the cube around it, and this code gets generated by the AI. Yeah, and okay, and then I go even further. Like, okay, I'm jumping a little bit. And then I basically said, hey, give it a German flag and the Greek flag, and then I say, hey, the Greek flag now changes when I mouse over. And then, okay, is it working? Then I explode it because we don't need the German flag anymore. And finally, the cool thing, do you see this here? Double the size of the cube. I paste it in Greek. Because it's an AI model, it can do that. Yeah, so this is a little bit how the future of like those interacting with those 3D things may be. I wanted to finish my talk with that to give you an idea of where the future of development may lead. And with that, I'm sorry if I went a little bit over time, but questions, answers. I will be around also tomorrow if there's happy to interact and talk more about all those things.
Thank you very much. Thank you very much, Andreas. I think they can find you outside. I saw the demo live yesterday, so I'm one of the lucky ones, so feel free to find him to show you the demo. We don't have time for Q&A, but we have this nice present for you. Thanks a lot for being part of OpenConf.
Thank you for coming today.